Today we're looking at the problem subsets. This is a really classic interview problem and one that introduces the concept of backtracking, which is not something you'll see a ton in interviews. You will see it, but it definitely helps a lot to understand recursion and dynamic programming, so it's very good to know these patterns. What this problem says is we're given an integer array nums of unique elements, and we want to return all the possible subsets. So if we look at our example here, we'll see we have the array 1, 2, 3, and we're returning the empty collection and then every combination of numbers that we can form from these. So as you can see, it's pretty self-explanatory what we're trying to output. We want to have unique subsets, so we're not going to see this one more than once. Everything's unique, just every combination, but unique. So as I said, we're going to use backtracking to solve this, and backtracking is a pretty inefficient algorithm. If you look at the constraints for this problem, you'll see that our length of nums is less than or equal to 10, right? Very, very small. And this is a good indication when you see something like this that we're going to use some sort of brute force algorithm like backtracking. So let's actually hop into an example and see exactly what this might look like. So here we're just going to use the example that we're given 1, 2, 3. And we want to generate every possible combination of elements from this array. So what we would do is use recursion with backtracking. And you'll kind of see what that backtracking means as we go through the example. So here what we're going to do is start with an empty collection. And we're going to iterate through each element of this array. And at each element, we have to make a choice. So let's start with 1. So here, we have to make the choice of whether to include or to not include this element. And if we include it, we'll have a subset of just 1. If we don't include it, still empty. Then we move to 2. We have to make the same choice. So we either include it, so we have 1, 2, or we don't include it and we still have 1. Similar here, we have to make the same choice. We either include it or we do not include it. Then finally, we go to 3. So we have to make the same choice. So either here, we can include it or we cannot include it. Same here. We can either include it or we cannot include it. Similar here, we can include it, not include it, and then likewise here, include or not include. So you see, just going through this process of making the decision for each element, we've generated all the subsets that we see in our answer. And we did this in 2 to the n time. And what does this mean? So it's 2 to the n because we have n elements. And for each of these, we have to make the choice of whether to include or not include. And you see that at the end of this whole process, we have 1, 2, 3, 4, 5, 6, 7, 8. So the math actually ends up being we have 2 to the 3, which is 8 subsets. So generating subsets is always going to be a 2 to the n operation when you're doing it recursively like this. Likewise, if we had 2 to the 4, this would obviously be 16, etc., and it'll just increase like that. So the backtracking comes in, it's that when we make this choice and go through all the options, we want to then undo it and look at all the possibilities where we didn't make that choice, right? So that's kind of where the backtracking comes into play. Every time we make the choice, we want to play it out and see what subsets we can make, but we have to then undo it and then see what other choices we can make in the future. So you'll see when we get into the code, but we're kind of doing this process of adding in an element, trying it out, seeing what subsets we can make with it as part of our current subset, but then removing it and moving on. So I think it'll be more clear in the code. So let's hop over and look at exactly how that works. So the first thing we do here is we set up this answer array. So this is going to house all the subsets that we generate, and it's what we're going to return for our final solution down at the bottom. So next, we're going to create this recursive function. This is what's going to be used to do all our backtracking logic. So this takes in our index, which is just the index of the element we're looking at, the current subset, which represents the current subset that we're processing starting at this index, and then also the answer. And this answer is just where we're going to put the subsets that we do generate. So first we have our base case. And this says, if we've already looked at every element in the list, then we just, whatever we have right now in our current subset, we're going to add that to our answer and return. That's our base case. Otherwise, if we don't hit this, we still want to add whatever this current subset is into our answer. Because remember, we want every subset, not just the ones where we've already gone through every element. If we're seeing a subset, the way this is set up, we know it's going to be unique. We know that we have unique numbers, so it will always be unique, and we can add this into our collection. So then once we add that in, what we're going to do is then do the process of trying out elements and then backtracking them out. So we're going to iterate through every element from our current index to the end of the array, and we're going to say, I want to add this element in to our current subset. Then what we do is we call that recursive function with the next index with the subset that we just added the element to and our answer array. And then afterwards, we're going to remove. And this is where the backtracking happens. You can see it's kind of a 3-step operation. We say, all right, I'm going to add this element in. Let's try it out. And then we're going to remove it and move on to the next element. So then at the end, what we do is we're just going to call that recursive function and finally return the answer. Let's submit and make sure this works. So yeah, this is the recursive backtracking approach to this problem. Very important to understand. This is going to be a similar pattern you'll use in a lot of more advanced backtracking and dynamic programming problems. So really good to know this problem very well. Hopefully this was helpful and you understood, and thank you for watching.